The average daily volume of a computer stock in 2011 was mu equals 35.1 million shares, according to a reliable source. Stock analyst believes that the stock volume is different from the 2011 level. 2011 level. So apparently we're talking about a two-tailed test here. We don't know that it's higher or lower in 2014 compared to 2011, just that it's different. Based on a random sample of 40 trading days in 2014, he finds the sample mean to be 29.3 million shares with a standard deviation of 13.4 million shares. Test the hypothesis by constructing a 95% confidence interval. We can only do this with a confidence interval because this is a two-tailed test. So it's about mu in both of these. In the null hypothesis, it's always an equals. And since this is two-tailed, not equal in the alternative hypothesis, compared against the same number of the 35.1 million shares. So, interesting. They are not showing us the link for the critical values. So I'm going to try two options here. First of all, since that is a 95% confidence interval that we're talking about, confidence intervals are two-sided with that plus or minus. And the way the table is set up, so we're only seeing, instead of 95% in between, we're seeing how much is in the right tail. So I need to take 100 minus 95 divided by 2 and convert that to from percent to decimal. So I'm dividing by 100%. 100% is equal to 1. And so I haven't changed the number. I've just changed how it's expressed from 2.5% to a pure decimal of 0.025. Since the sample size was 40, there are 39 degrees of freedom. And we're looking at the 0.025 column right here. 39 degrees of freedom. I am seeing a 2.023 for that critical value. 2.023. On the other hand, what I could have done was second and above ours is distributions. Inverse T. We're looking for an area of 0.025 with 39 degrees of freedom. That's talking about the left-hand tail. That's why it's negative. But since the formula for a confidence interval already has that plus or minus, I'm going to take the absolute value of that. And if I round that to 3 places, I would also have 2.023. So 2.023. Your formula is to take X bar plus or minus the margin of error. X bar was the 29.3, the sample mean. Minus for the lower bound. We would multiply to get the margin of error, multiply the critical value times the sample standard deviation over square root of n. If I remember correctly, standard error is S over square root of n. 13.4 divided by square root of 40. And then I'm going to change that to a plus to get the upper bound. And we are supposed to round to 3 places. So the first one rounds up to 25.014. And the Second one rounds down to 33.586. So apparently it didn't matter which one I would use. Now, the claimed mean of 35.1 is even less than the lower bound. So this would appear that we should reject H naught because the claimed mean of this two-tailed test is not within the lower and upper bound. It is specifically above the upper bound, but it could also have been less than the lower bound, and I'd conclude the same thing. Reject the null hypothesis because it does not fall within the confidence interval. If it did fall within the interval, if the claim mean was between the lower and upper bound, then I would fail to reject it.